Hello everyone, welcome you all. In this video, we'll discuss about insertion sort. Insertion sort is a sorting algorithm which works like it will divide your given input array into two partitions of one will be a sorted partition and another will be an unsorted partition. And it will keep on bringing elements from unsorted partition to the sorted partition and will place it at its right index. This is how the insertion sort will work. We'll see with some examples and code as we progress through the video. Let's see some properties that insertion sort has. It's an in-place algorithm, means its space complexity is big O of 1. Its time complexity is big O of n square, which makes it a quadratic algorithm, and which means that if we'll increase the number of elements to sort, then the number of subsequent steps to sort those elements will increase significantly. Suppose if we are sorting 10 items, then we need 100 primitive steps to sort these 10 items in the given array. If we have 100 items to sort, then we need 10,000 steps. So similar, as we are seeing that as we are growing the number of items, the number of primitive operations, they are increasing significantly. Hence, we see that its performance will degrade as the number of items grows to sort. Insertion sort is a stable algorithm, which means that if there are any duplicate elements in the array to sort is given, suppose two nines are there which are duplicate. So since it is a stable algorithm, it will retain the relative position of duplicate elements, which means that when this array will be sorted, when this entire array will be sorted, then this 9 will always come before the 9 which is following it. And it happens because when we are picking items in insertion sort, we are doing it from left to right. Example we will see in when we'll do an example of insertion sort is that if there are two nines in the array, we are going to insert the leftmost 9 first, and when we come to the rightmost 9, we'll stop as soon as an element is less than is found, else it stays as is. And since the other one is not less than, so it will stay as is and it will follow the other one. In this video, we'll write a function called insertion sort, which will accept an array of integers as an input and will sort all the elements. We'll also observe while writing the code that in each iteration, when we'll finish one iteration, what will happen in the iteration is that we'll take one item from the unsorted in partition and place it in the sorted partition and then insert it at its correct position in the sorted partition. Okay. Let's see through an example that how we will work with the insertion sort, or how insertion sort works when given an input array of integers. So here in this case, we have an input of 465, 5 and -1 as the elements to be sorted. So when we'll start with this algorithm, we'll define few variables in our work, which will first will be a variable called first unsorted index. This will be the first index of the unsorted partition. Also, one more thing, like what happens in the insertion sort, that it claims that the first element of the array, if it is taken into a sub array, that it behaves as a sub array, then it is always sorted. And we also will advocate that if there is only one item in an array, then it is a sorted array by definition. So in this case, our unsorted array will start from index 1, which is 65, 5 and -1. So first unsorted index will be 1 for us. The other variable we'll take is I. This index will be used to traverse the sorted partition from right to left. As some time back we were discussing that we'll keep on pulling items from the unsorted partition and putting into the sorted partition and then placing it at its right. So this I will help us in traversing through the sorted partition, and it will initially it will start with 0. The next variable we'll take is new element. This new element is the one that is coming from the unsorted partition, which is the value at first unsorted index, which is 65 in our case. So what will happen that when in the first iteration, when we'll pull one item from the unsorted partition, which is 65, which is coming over here, then we will check that if it is greater than the index which I is holding or not. In this case, 65 is greater, which is the correct scenario. So we'll leave them as is and we'll increase I and first unsorted index value. And the new array will become as 4, 65, 5, minus 1. And since 65 has moved to the sorted partition, so we will consider it into the sorted partition, and this will be unsorted partition. And then we'll increase I to 1, first unsorted index to 0 to 2, and the new element will become 5. Here in this case, in the next iteration, when we will be comparing 5 with the next its element, as we have already taken that the new sorted partition has got elements of 4, 65, 5, and this is virtual actually. This is just a virtual because we have not assigned 5 anywhere as of now. We'll assign it in some time. We'll see how it gets assigned. So we have, I mean, this is just to show that 5 is coming to the sorted partition, and then we'll place it at its right position. Okay, so this is just a virtual picture. So we will compare 5 with 65. We observe that 5 is less than 65. So we'll assign 65 to its position and increment, and we'll decrement the value of I, so that we'll again compare it with 5 with its next positioned element. So when we will compare 5 and we have found that it is less than, so the new array will become like this: 4, 65, and 5 will be replaced with 65 because we have identified that 5, the position of 5 is not correct. So we need to find its side index. Now in this case, we will be incrementing, decrementing the value of I, which will be 0, which will be 1 now. And don't worry, like as you can see that 5 has disappeared over here. So we will not worry about it because we have one variable called new element, which is retaining the value of 5. It's not lost. It's just that we'll make few comparisons and then we'll get back. So in this case, when I is 0 and we'll be comparing the 1th element with 0, we find that it is greater than 5 is greater than 4. 5 is greater than 4. So it will, we have got to know that this I is the right index for 5. So we'll assign at I is equals to 0 the new element. So the final array will become 4, 5, 65, and minus 1. So this is the element array that has come after the second iteration. Similarly, we'll do the comparison and iterations for the last element, which is minus 1. Let's go and have this insertion sort code running and see how it works. So here in the IDE, we have a driver method called main, which is having an insertion sort method, and then we are streaming that array to print all the elements. We'll check it out that the input that is given to the insertion sort has been sorted. So firstly, we'll create a for each, which will start the uh, pulling all the elements from the unsorted partition to the sorted partition. So we'll name it first unsorted index. It will start from 1 because 0 has already been captured by sorted partition. So first unsorted index should be less than input.length, and then we'll keep on incrementing first unsorted index because we are doing the sort of partition that is growing from left to right. So next we'll have a variable called new element, which as we discussed some time back that it's gonna be the element at first unsorted index. Then we'll have one index I, which will keep the track of the index to be uh, corrected in sorted partition. We have kept it outside this for loop because we need it outside the for. So what this I will start from the first unsorted index because this is the index which we have moved from, which we have identified from the unsorted partition to be part of sorted index. So it will start from first unsorted index, and then it will have few conditions like if it is hitting the front of the input array, then it should uh, end. And we have one more condition that if this input array's value at index I minus 1, which is the comparison which we just did some time back with new element, if this is greater than the new element, then we got to break. And if it is not satisfying, then we see that it has got its position at the right place. And now we'll decrement the value of I index. Now we'll shift the values which has we shift the value of the one that is coming from the unsorted partition into the sorted partition by substituting it with I at input I minus 1, which this is a scenario in which we saw in the example back that it was having the duplicate element in the array. So in the last step, we'll assign, since we have identified that it will break at I, where it has found that the element which has come from the unsorted partition is greater than the value which is present in the sorted partition at this index. So we will provide that index with the value of new element. This is the code that will do the insertion sort for us. Let's run it out and check whether it works or not. Okay, so we had given few arguments for the sorting, and here is the result that minus 5, 5, and the greatest element was 45. So similarly, you can try it out. Thanks for watching this video. Please subscribe to Code is Good to encourage making such videos. Thank you.